everyone. Nice to meet you. I want to thank for the former presenters for all the information and context provided, which I think is gonna be very useful for this presentation. So first of all, just a brief introduction on Alcyon Photonics. We're a spin-off from National Research Council, and we base our design technology on a Symbolic ratings. We'll cover much later. So first of all, it's the problem-solving approach, or why is Alcyon Photonics born, and most of the topics have been covered on BLC presentation, on iTronics presentation. I think it's very, very interesting what they share is we all acknowledge that photonics need to accelerate its adoption because electronics can no longer meet the demand for growing communication and computing. But on the other hand, as the former presenter introduced, current photonics ecosystem is not ready to the speed of time to market and the cost that are necessary to make photonics a massive technology. And some of the approaches that have been shared here we fully acknowledge is we need to work in a more EDA model similar to the electronics model, which means we need to make user easier to reduce its development and cost time, and finally, and this was also mentioned on the former presentation, to make sure that we can qualify the photonic integrated circuits in order to be massively adopted for key industries such as automotive or communication. So in line with this more or less call it a structured approach, a less customized way of working, we work in designing building blocks and photonic integrated circuits at some of the company that has been working here before, but the different is the different approach. The way that we think we need to build these blocks is in a way that the customer can find very easy to build its own solution. So that's why we use this Lego picture here, because the idea is that we think that we should provide end customer, which doesn't mean you and I as persons, but it means companies that are already building devices in communication, in sensoring, in computing, and probably are highly knowledgeable in terms of electronics, but obviously like the deep knowledge that is required to design in photonics, and that brings all these highly literate people into this field. And as we mentioned, and it's been mentioned before, there's a lot of knowledge in the academia, but it needs to be transferred into industry, and there's a clear gap because probably most of companies don't need to know how photonics works, but what they need to know is what photonics does. And that's what we intend to do through our libraries, provide the end customer with very basic building blocks in terms of functionality, with a very high performance that enables end customer to build any end application that they had in mind without needing to have all these iterations that are required in terms of designing for a primary building blocks that are required in order to validate that the overall circuit is working properly, or all these iterations that are required in order to make sure that this design is working properly in a foundry, because what we are providing to the customer is a library that is validated for a foundry and that has high performance features, so they know what the light needs to do, but they don't need to know how we make it. So that's our approach to this market and to the problem of the adoption of photonics. And how we do it, and this is probably our core strength, is through a very unique technology. This technology is called Symbolic ratings. As you can see on the slide, it's basically traditional waveguides are just a single unique monolithic structure. And the way we address the science is that splitting these waveguides into very periodic structures, which period is below the wavelength of the light that is being used on that block, and which behaves in a different way compared to traditional waveguide. Basically, what happens is that the light sees as a more seamless materials and presents a very, very different behavior. This allows us to provide new advantage into design. First of all, it's very easy fabrication compared to some other structure. Second thing is that by adding this period between the small wave gratings, we open a new design exists, which means we can manage new properties and allow us to build an anisotropy and dispersion control. What is also been measured in this technology is one of the key advantages is that it's providing very, very wide bandwidth to our devices. We are talking about covering O, C, C, and L bands in many cases, depending on the designs. Second thing is the designs are extremely compact. And finally, and it's something we mentioned sometimes, that it allows us to manage the light for some specific functionality that has not been properly addressed before. How it lands in terms of product, and we'll be mentioning this in the presentation, is we think that end users need to have a set of blocks which can be used very easy to implement any end function that they want. It's when you're addressing a transceiver, it's been named before an interrogator or an OCD, it's very difficult for a customer that comes from electronics to get all this knowledge into photonics, to develop all this knowledge on the photonics fabrication, on how that photonics is being measured. So we want to make the life very easier by having this comprehensive set of functionalities that allow us to build very fast and easy any AMP application. And the good thing is that this has been mentioned before also, that it has very transversal application areas such as telecom, datacom, sensoring, quantum, etc. And where we think that we can really provide a very, very differentiating value for photonics to be adopted. Our product, and it's been mentioned before, is basically delivering all these designs. And we have this proprietary technology, but and this thinking more in the midterm, we are very open to also incorporate other players' IP, because we think the electronic model has worked very well in that sense, in the sense that incorporating IP is very easy. Doesn't require, as of today, a lot of investment into research and development and business development, because it has very structured channels and companies that devoted to delivering all these IP into a very productized way. What's happening now, and we're seeing every day, is that academia has a lot of knowledge and IP development, and there's a chance that makes it very difficult to deliver this strong knowledge and IP into the market. And basically, it's because it requires a long time. It requires processes, it requires knowledge from another side that is not so common into the academia, and it's about the fabrication and delivering into the real world. And this is a bridge that we also want to cover. So basically, that's what we are approaching the market in a different way that has been explained before. It's in a B2B2C model through these libraries, which should be enabling end customers to build their own designs very easily and without needing really deep knowledge on photonics. So that's more or less what we do. Thank you, guys.